Okay, the subject today is to talk about 10 gig Ethernet. As I said, there we go. Let's see if we can get the screen working. There we go. As I said, it's from myself and Dorothy. Dorothy's looking after the network infrastructure as a product manager, and myself, as Quay said, I work out of Advantech Europe and get involved obviously in the data communications side of things. And they always say apologies are never something to do in a presentation, but again, I apologize for the scary photo on the right hand side of the screen here. What I'm going to talk about, give you a general introduction as to the driving forces behind higher speed Ethernet being deployed in the OT manufacturing infrastructure. Then give you a couple of case examples or case studies. These are actually real live projects that we're currently working on. And then finally round up by giving you the roadmap on product development. So, first thing is, what is 10 gig Ethernet and what, more importantly, is driving the need for it? And it's really quite straightforward. We're generating more and more data within the machines or within factory automation. The old days from many years ago when you could happily use and rely upon low-speed communications like RS-422 or even RS-485, those days have kind of gone. As I said, machines are generating more data. Factory installations, we're looking at more the ability to be able to collate and use data generated by an entire manufacturing process. Some examples are things like analytics, machine learning, video analysis for machine vision, and also obviously deep learning and the ability to use higher end servers to be able to manipulate, manage and predict data or predict production systems based on data that is currently being generated in real time. How does it look when it comes down to the actual hardware? Well, in the good old days, and still even to this day, with standard 10-100 Ethernet, things like our controllers, cameras, HMIs, and our local I/O quite happily live with these lower speed versions of Ethernet. But what we're seeing, or we started seeing about 2 to 3 years ago, is more of a drive to gigabit Ethernet for things like high-speed digital acquisition, edge computing, which is an area Advantech is very strong in with the UNO systems where we do edge processing, machine vision, which I'll talk about later on as well. Meanwhile, all that data that is being processed at that level is being passed up to higher levels, and this is where 10 gig Ethernet really does kick in as a protocol or a access speed that is required in production or OT networking. For example, our AI systems, network storage, or multi-node servers will sit at the top of the tree. Another way of looking at this in a more picturesque approach is to basically look at our core networking speeds, in other words, the speeds in which the various devices need to be able to communicate versus the application. And I said on the previous slide, our lower speed edge devices, sensors, compressed video, etc. are quite happy with standard Ethernet as we know it. Our edge processing, as I said earlier, for example, things like the UNO as the edge, handling uncompressed video data aggregation need higher speed. And then again, the driving force for 10 gig is all that data is slowly moving up the food chain to where we have our core processing systems like vision analytics, cloud gateway in, for example. There is a big drive now at the moment to use a hybrid cloud approach system where we have an on-premise cloud, and in addition to that we have our cloud, if such a term even exists. So we need a high-speed backboning into that sort of area. So 10 gig, well, it's pretty straightforward, as I think I may have hopefully illustrated on the previous two slides. The key thing is we have a lot of data now flowing around our OT manufacturing networks. We need higher speed backbones or higher speed data transmission paths to move that information further up to the analytics and the higher end systems which are using the data to make decisions based on current manufacturing status for predicting forward for future manufacturing status and production. What does it look like? Well, we've got a very simple slide on the screen here to illustrate how we would deploy or use 10 gig. We have basically an edge switch with high-speed copper downlinks for the access devices, be them cameras or NVRs or high-speed DAC, and then obviously taking all that data, for example, 24 1 gig ports working at 100% utilization. We obviously need the highest speeds offered by 10 gig. One clever trick, which I'll talk about when we look at the switch specifications later on, is we have the ability to do something called LACP, which is link aggregation. So literally we can turn the 4, in this case 10 gig ports, into actually one bonded pipe of 40 gig, which would then go into the higher end servers or higher end switches, and then the data would go to wherever it needs to be. So, I mean, basically to summarize, as I think I've illustrated over the last few slides, 10 gig, obviously, we have the much higher bandwidths available now for the types of application we're targeting with 10 gig. Transmission speeds, obviously, with 10 gig backboning, we have non-blocking architecture, which means we can guarantee 100% the data will be delivered correctly and in time for the processing. So it's more like you can view it as aggregation. And, you know, as I said on the introductory slide, the driving force really now is the new applications we're using in manufacturing OT environments. And I'd like now to quickly talk about a couple of examples that we're actually working on at the moment. Key thing, or one thing that we've always been very strong with as a company, is, for example, IP CCTV surveillance systems. We have literally hundreds of installations worldwide where we're using our standard switches to provide IP CCTV security observation, be it based upon a metro campus or even citywide. And, you know, standard gigabit switches normally are more than ample for these types of application. If you look at, say, the new camera technology, even a 4K HD that's using MPEG-4 compression doesn't really need all that much data bandwidth, normally 20 to 30 megabits per second. However, there is a change happening in the way we're building these camera networks. As opposed to having a single NVR video analytics system, a lot of customers are now moving more to a distributed style system. So there'll be multiple NVR analytics systems on the network. And as you could well imagine, since we're now targeting multiple devices with the video streams, we're exponentially increasing the amount of data on the backbone. 1 gig in those types of installations is no longer sufficient. We now have to look at using 10 gigabit to be able to solve the problem of being able to feed video to multiple NVR systems out there. Other area, again, involving cameras is machine vision. Again, this is a market that Advantech as a company is getting heavily involved with. For those of you who may be unfamiliar or a little bit unsure about machine vision, the simple concept is we're using camera and then the data coming out the camera to be able to analyze the production. And that production could be, for example, a PCB, ensuring that all the chips and all the soldering has been done correctly. It could even be something as crazy as a mixed bag of potato chips to make sure we've got all the right flavors in the bag. The key thing with machine vision, though, obviously, is the analytics of the data from the camera. And there's three generic approaches. We could have a highly intelligent camera with all the CPU and the software built into it. That obviously doesn't need high-speed data connectivity. It works great, but the problem you get there is those cameras can be very expensive. Can be anything between €1,000 to €4,000 per camera. The second approach is to use just normal cameras and then have some sort of vision processing board installed in an edge computer, which again increases pricing. Or the third approach, which is becoming more and more prevalent now in the industry, is to literally take the raw streams from the camera to a central vision processing system, which is loaded up with lots of memory, CPU, graphics cards, etc. The cost per camera actually will come down, and also you have expandability. The challenge we have taking the third approach, though, is we're taking video streams from the cameras in raw format. We are not using any form of compression, simply because compression is never 100% accurate. We'll often introduce something called an artifact into the video. That's basically where the compression algorithm hasn't been able to handle the feed correctly. So if you're doing machine vision inspection, compressed video is something you have to avoid. You need the raw video for your video analytics system to be able to make decisions on there. Other challenge with machine vision as well is frame rate, for example. Typically a standard camera that you'd see, I don't know, installed in the street, say for example number plate recognition or something for security, normally shoots anything between 16 to 24, maybe 30 frames per second. Quite often in machine vision, we're using cameras which have a much higher frame rate, sometimes 120 to 240 frames per second. So you can imagine if we're shooting at that frame rate with uncompressed data, we're going to be generating a lot of data coming out of these cameras within the world of machine vision. 1 gig sometimes is enough. Sometimes we may even need to have to go to a 10 gig feed to be able to support the camera correctly. So machine vision is a developing market, and it's a market that certainly, as a company and also from the ICG product division perspective, is an area we are getting heavily involved with. Okay, so the product roadmap itself, just to introduce you to what we actually have available. Currently, we're shipping a pretty straightforward switch with 8 gig downlinks, 4 10 gig uplinks, PoE with network management. Coming through towards the end of this year will be an unmanaged switch, which supports 8 times 10 gig. This could be of interest into the machine vision people. Obviously, in the world of industrial, any form of networking, there's no such thing as a customer with unlimited budget. And our own experience has indicated that quite often the machine vision guys are rather price sensitive when it comes to the network infrastructure. So the ECI 2408X is designed to give a low cost, high speed switch for machine vision connectivity. Coming through towards the end of this year in November, we have a rack mount device offering 24 gig downlinks together with 4 SFP uplinks, which is obviously 10 gig. That will be available with or without PoE capabilities. And obviously the earlier example I gave of using 10 gig in the world of IP CCTV, the PoE version will be of interest to those guys. And then coming through next year, possibly around about Q2, will be the big brother of the 7428G, which will be the 7454. It will offer you yet more downlinks up to 48, either with or without power over Ethernet. And since our port count now is gone beyond 24, we'll actually offer you 6 10 gig uplinks capability in that switch. Product highlights. Well, this is a webinar, not me reading out a data sheet to everybody. But there's a few things to talk about. Temperature support, 0 to 60. There's no real need for -40 to +75 in these types of application, due to, for example, in the world of machine vision, quite often there is factory environmentally controlled areas. Link aggregation, as I mentioned earlier on, so we can actually create much higher speed uplinks. Layer 2 managed or unmanaged, as I talked about on the previous slide. For installations that get a little bit bigger, we also support ring protocols, X-ring, which is the Advantech developed high speed and low latency ring healing system. We also support standard IEEE protocols like rapid spanning tree and MSRP. And then also, being an Advantech product, we support the IXM functionality in these managed switches. For those of you who may be unfamiliar with IXM, this is, as I said, an Advantech developed technology which allows the mass provisioning of switches to go much, much smoother than the traditional way. Deploying IXM allows us to push IP addresses or IP address ranges out to other switches. We can also push out configuration information, things like the ring configuration, VLANs, QoS, PoE, etc., directly from a PC running a standard web browser. Give you an idea, a few years ago, myself and one of our FAEs and one of our sales guys wandered off to go help out a customer. It was his first big install. There was about 240 switches on 3 rings, and we did a complete software and configuration upgrade of 240 switches in an afternoon. That evening, when we were having dinner with the customer, he did mention that a previous installation he did, unfortunately not using our switches but using switches from one of our competitors, it took them 5 days to achieve what we did in an afternoon. So IXM is a very powerful function and tool available on our managed switch family. Obviously, we're dealing with gigabit and 10 gigabit, so quite often we may be using fiber optics for the connectivity. In the world of 1 gig Ethernet, we have a series of SFP transceivers supporting multi-mode fiber, single mode, and also single strand fiber. For those of you unaware of the technology here, normally fiber optics, you need 2 strands of fiber, one to transmit, one to receive. Single strand optics actually eliminates the need for a second strand, so we can use a simplex connection, 1 strand to connect 2 devices. So we can reduce cabling costs or double the capacity of a previously installed fiber system. And in the world of 10 gig, obviously, since we're talking about 10 gig switches, we have SFP pluses, multi-mode version. The distances you can achieve over multi-mode is normally dependent on the type of multi-mode cable installed, OM3 or OM4. And then lastly, of course, we have single mode capability, which will support distances from 0 to 10 or 0 to 40 kilometers, depending which module you buy. Since they're SFPs, they're pretty straightforward. Everything's hot swappable. We have digital diagnostics within the SFP, so you can see things like your transmit strength, receive strength, operational temperature of the SFP as well. And talking of temperature, all these SFPs support wide temperature, and they're designed obviously not only just to fit into the 10 gig switches I've been talking about now, but into any other switch manufactured by Advantech as well.